Okay, so in July 2005, professional skateboarder Danny Way jumped over the Great Wall of China. His path can be modeled by the relation h equal negative 0.05 d squared plus 1.15 d, where h is the height above the Great Wall and d is his horizontal distance from the takeoff ramp, both in meters. Determine the distance between Danny's takeoff and landing. So, first thing that I want you when you read this question, I want you to identify what h and d represent, right? It says in the question exactly what they represent, where h is the, what does h? It's the height above the Great Wall, and d is horizontal distance from the takeoff ramp, okay? So this is your takeoff, this is a takeoff ramp, right? And then he's gonna go up like this, right? This is the height of above the Great Wall, and then this is his horizontal distance, right? Something like this. Now this is just a sketch. Now, determine the distance between Danny's takeoff and landing. So what am I finding?
There are two zeros because Danny's takeoff is the first zero and then landing is the second.
And how did you know that Danny's takeoff is the first zero? That's right. How did you know that?
Landing, because landing, we know that landing is the second one.
That's right.
Yeah, so obviously, I don't know how to describe it. Because landing, when in case of the ball, when we're taking the ball, it's going back to
the ground.
So we know from there that that's the second one.
Now the first one doesn't have to actually be a zero. It could be the y-intercept, right? Because remember that your takeoff is when you start the motion, right? This is when you're taking off. Do we agree with that? So your initial height is your takeoff, right? You could be taking off from the middle of the air. You could be taking off from the ground, right? It doesn't have to be always from the ground, your takeoff. Now, the takeoff is the initial height. Give me another word for initial height. Give me, when I say initial height, what are you looking for? The y-intercept, right? When I say initial, I mean the y-intercept. Looking at this, can you tell me what your y-intercept is? What is it?
0.05.
It's zero. It's zero. This is missing the last term, which is zero. Right? This is standard form. This is missing the last term, which is a zero. When it's missing, it's a zero. Okay? Now, so that means, Nilofar, you're right. He is taking off from the ground in this case. Right? But it's not always the case. Remember the motorcycle that left from a ledge? Right? Remember that question where the motorcycle left from a ledge and then he jumped, right? Or she jumped, right? The initial height was not the ground. He was standing on a ledge, right? Or she. So, so in this case, you have to understand that I'm looking at from the starting point to the landing point. The starting point could be the ground or could be somewhere else. Okay? So I know that the initial or the y-intercept is 0, right? So that means the initial height is is 0. Good. Now in order to find the second x-intercept or the x-intercepts, what do I need to do? What form do I need to put it in?
Finding what?
The x-intercept.
We need
You put a factor form?
Factors form, right? So how would I factor this? You said something. The greatest common factor. That's the first thing you want to ask yourself, right? So I have to put it in factors form, and I need to find the greatest common factor. What would be my greatest common factor for this?
0.05.
Negative 0.05. Remember that if the first term has a negative, I want to take it out. Any other things? Any other numbers or letters? D. D is common for both, right? And then the lowest exponent is D, right? It's not D squared, it's D. So negative 0.05 D. And then I will divide each term by negative 0.05 D. And this is where a lot of students don't know what to do because they have two terms. They'll stand there and they will look at it and they will not figure out what they need to do. Okay? So it's going to be D minus 23. Yeah? Okay. So, what are your zeros? Positive 23. You only have one zero here?
Yes.
Are you sure?
Because the other one is, if you just starting it from the ground to zero, so it's
How many zeros do you have? Which is?
it's 0 and negative 23.
0 and positive 23. Remember, guys, and this is why I chose this question. Guess why? Because you're going to have something like it on the test. This is also a 0. You have a letter there. It's D, and D is equal to 0. We've already determined that the initial height is 0. And in this case, it is also, it's not only your y-intercept, it's also your 0, it's also your x-intercept. It's two at the same time. It's an y-intercept and an x-intercept. So let's see how that is gonna play. So if I graph this, so he starts right here, he's gonna go up, and then he's gonna land at 23. Right? This is what I know so far. Now the question is very clear. The question is asking you, what is the distance between Danny's takeoff and landing? What is the distance between his takeoff and his landing? 23 meters. Right? That's the question. Now, question for you, for all of you, right? Let's say Danny did not take off from the ground. Let's say Danny took off right here, right? So what's going to happen is you're going to have something that would look like this and then this. Do I count the distance before Danny's takeoff?
No.
No, because Danny took off from here, not from negative distance. Does it make sense right now? When do you use that negative value and when you don't use it? Right? Because it's asking you from his takeoff. His takeoff is at time 0. Okay? Now, and this is not the scenario. Now, Danny took off from the ground, went up, and then went back down on the ground 23 seconds. We know that you can write this. The distance between Danny's takeoff and landing is 23 meters. Now I'm going to add to this question, and I'm going to ask you what or when, at what horizontal distance did Danny reach his maximum height? So what do I need to find? What am I asking you to find?
Y
What is it?
0 and height.
I will repeat the question.
Yeah.
At what horizontal distance did Danny reach his maximum height?
The edge of
The axis of symmetry. At what horizontal distance? This is the horizontal distance, the x value. Right? We already defined that. The horizontal distance is the x value. So at what horizontal distance did Danny reach the maximum value? So basically, if I do this, right, I'm looking for the horizontal distance. So he reached the maximum value. How would I find the axis of symmetry? Add the zeros and divide by 2. This is what we learned yesterday, right? Yeah. So to find the axis of symmetry, I'm just adding to the. So what is? So then you reach the maximum height at 11.5 meter horizontal, right? Make sense? Yes. Okay. Now, what is Danny's maximum height? What do you have to do to find his maximum height? You have to find the optimal value, and how do you find the optimal value? Plug in the axis of symmetry for, in this case, t. The way to find it is not going to change, right? If you're looking for the optimal value, you're going to have to plug in the axis of symmetry, right? Now the question is changing, but the way to find it is not going to change. So the height is negative 0.05 d squared plus 1.15 d. Is that right? Should be 6.6 meters.
This part is not adding the question, right?
This is I'm adding to the question. This is not part of the question.
No, that's what
The part of the question ends at the horizontal distance. Yeah.
23 meters.
Guys, we don't have a lot of time left, and things has to kind of speed up a little bit, just so you know. Okay, so our next unit is going to be pretty fast. So get ready to finish 2 lessons today. The next unit will start on Friday. Tomorrow we have a test.
How many pages?
Don't know.
What is the misdemeanor assessment?
What?
What is the misdemeanor?
Probably, I'm gonna start with trigonometry.
With what?
Trigonometry. It's the triangle. Okay. So, are you guys ready for kind of a full picture of what we learned?
Yes.
Let's look at this picture, okay? Can I move to a different page?
Can I just leave it at 10:20?
No?
Can I leave it at 10:20? I have an appointment tonight. I want to talk to the family.
Okay. All right. So for this, you kind of need it doesn't have to be a graph paper. It's more like a landscape paper. Okay. So you're gonna need more space horizontally. Okay. Then vertical. So what are the three forms of quadratics? Good. So standard. Actually, I'm gonna put standard in the middle. So we're gonna start with vertex. Then we have standard. And we have factor. Anyone doesn't know how to identify them. So if I give you a question, you tell me right away if it's factored, vertex, or standard? Kind of? Okay? Now, what can I find from the standard form? What can I find from the standard form? The y-intercept. What can I find from the vertex form? And which is? Can you tell me more about h? What does h represent?
X and Y.
Okay. What does the k value represent?
Horizontal. No.
Optimal value.
Good. How about factored form? What do I know from the factored form? I can find the zeros, right? Or we can call them also what? X-intercepts. They're the same thing, same. It's also called find the solution, solve. When the question is asking you to solve, you're solving for the x-intercept, right? And then you can find it by setting both brackets to 0, right? So you set x minus r equals 0, so x equals r. And then you set x minus s equals 0, and x equals to s. Are we okay with that? We understand that part? Yes. Okay. Now, this is a feature of each form. Now, if I want to know, if I have a standard form, and the question is asking me to find the zeros, or when the ball hit the ground, or when the motorcycle lands, or whatever the question is, what form do I want it to be in? Factored form. So I have to go from standard to factored, right? To go from standard to factored, what do I do? I factor. Right? How many different ways of factoring did we learn? 3 ways. The first question that you're going to always ask yourself is, do I have a greatest common factor? That can be done, and then you can use the other 2 methods as well with it. Okay? So you have to do either greatest common factor plus, right, one of the 2. What would be the one of the 2? Difference of squares and sum of product. Good. Now, what if I have the factored form, but I want to go to the standard because I want to find my y-intercept? What do I do? So I'm in standard form, and I want to go to, sorry, I'm in factored form, I want to go to standard form. What do I do? Expand. Right? We also know it as FOIL, right? But the question will not tell you to FOIL, the question will ask you to expand. Good. Do we know how to go from standard to vertex?
No.
No, we don't learn that here, right? Do we know how to go from vertex to standard?
Yes.
What do? Expand, right? Remember, when you're expanding, you're cloning, right? In this case, you're also expanding. I mean the other way around. My apologies. You're also expanding, and then you have to clone this. I've seen a lot of people make the mistake and change the sign. Do not change the sign. It's going to be minus h, whatever that sign is, minus or positive, has to stay the same, right? When you're expanding. Then you're going to FOIL, then you're going to multiply the a in, then you're going to collect like terms. Do we remember that? Good. So, this is the picture of the 3 different formats. Now, what if I am in factored form and I'm asked to find the vertex? What do? I'm in factored form and I'm asked to find the vertex. If I go to standard form, do I know how to go from standard to vertex? No. Okay, so going to standard form is not going to help me. How can I find the vertex knowing the factored form? But if you FOIL, you're going to go to standard form. Find the zeros. Find the axis of symmetry. That's right. So, to go from here to here, I have to find the zeros. Find the axis of symmetries by adding the 2 zeros. and dividing by 2. And then plug in the axis of symmetry in for x. To solve for the optimal value.
That's it.
For the
No, for this.
yeah,
So the axis of symmetry of the values are vertex, right?
that's right. So the axis of symmetry and the optimal value, they're going to give you your vertex. How can you put it in vertex form now? So now you're going to use your axis of symmetry, which is h, and you're going to replace it in for h and k, right? Yeah, so whatever you found right here is going to go, whatever you found for the axis of symmetry is going to go for h. Whatever you found for the optimal value is going to go for k.
You plug
Yeah.
in and then you solve?
You don't solve, you just plug it
You
in.
just plug in rate?
Yeah, so the axis of symmetry is going to go for h, and the optimal value that you found in the third step is going to go for k. Now, a question for you. What would a be? A. What would a? The value of a. What would it be? Will be the same as this. Okay? The value of a is going to be the same for all three formats. Okay? So the value of a here is the same as the value of a here is the same as the value of a here. If we're talking about the same function, obviously. Okay? So when I go from factor to vertex by doing these steps, the value of a is going to be the same as the value of a that I had earlier with the factors. Do we understand that? Now, let's look at the different forms of factoring, because we've learned 3 different forms. Okay, let's recap of what do we do. Okay. So for factoring, you're gonna ask yourself always, what's the first thing you're gonna ask yourself? Okay, do I have the greatest common factor? Right? Do I have a greatest common factor? If I do, then I have to factor it out. And then when you factor it out, you're going to have your greatest common factor and then the leftovers. Guys, I don't know how many of you forgot to keep the greatest common factor outside. I indicated that on your sheet. Right? Make sure that you have your greatest common factor outside. Yes, at all times. Your final answer should have the greatest common factor outside. Now, after you do that, you do that, you're gonna look at the leftovers, and there will be 3 different options, okay? Option number 1, you look at it, and then you're gonna say, I don't think I can factor this, and you stop, okay? Let's leave that till the end. Option number, the option that I wanna start with is called difference of squares. So if you have a binomial, so this is the leftover now. You have a binomial with squared terms and a minus between them. What do we call this? What do we call it? What do we do? How can I factor this? What do we call this? It's right there, somewhere. Is this sum and product? Difference of squares, right? If I have a binomial with 2 squared terms and a minus between them, then I have to follow the difference of squares. And that's going to be, so you leave the GCF outside, and it's going to be A minus B, A plus B. Do you guys remember that? The other option for the leftover would be if I have a trinomial. If I have a trinomial, how can I factor a trinomial? That's right. So sum and product. And that would be something that's multiplied to C and add to B. And then you will factor it with the factors. So it's going to look like this. The other option, as I said earlier, is the leftover is not factorable. So it could be either or, it could be this. Then you leave it like as is. You just leave it as a GCF and leftovers. You can't do anything. Right? So in this case, you can't do anything. So you can't find 2 numbers that multiply to C and add to B, or if you can't, or if it's not like square terms, or if there's a plus in between the square terms, these are not factorable, so you have to leave it. Now, what if you don't have a GCF? What would be your options? So no GCF, right? So you have two options. It will be if you have a binomial, so it could be a difference of squares. So basically it's like this, it's exactly like this, but without the GCF in the front. So it's going to be a squared minus b squared, and then it's going to factor to a minus b, a plus b, so your difference of squares. And then your other option would be a trinomial. And it's going to look like this. And then you're going to have to do sum and product. And you have to either multiply, not either, you have to multiply to b into c and add to b, and then write your factor as x minus r